This live Slooh show is brought to you by the support of Slooh members and the following sponsors. Visit slooh.com to become a member today.
Hello and welcome to Slooh's live coverage of Asteroid Day 2015. My name's Will Gator, and tonight on the show we're going to be discussing a somewhat controversial subject, certainly a fascinating one, and an area of astronomy that really has intrigued astronomers and the public alike for centuries, and that is the threat to Earth from asteroids. Now, we're celebrating Asteroid Day because today is June 30th, the 107th anniversary of the Tunguska event, when it's thought an asteroid or maybe a comet impacted the Earth and exploded in the atmosphere over Siberia, leveling trees and thankfully not hitting anyone or any parts of cities or towns or things like that. But what is the threat to Earth today? How likely is it that we're going to be hit by an asteroid in the near future? Well, all of these things we're going to explore in the show tonight, and we've got lots of experts to talk about this fascinating subject. Later on the show, we're going to be speaking to one of the signatories to the Asteroid Day 100X declaration. That's private astronaut Richard Garriott. We'll also be speaking to film producer Duncan Kopp about how asteroids have been portrayed in movies, and maybe have we given them a sort of a bad image. In fact, we're much safer than we think. And of course, we're going to be bringing you live images as well. And if you want to ask us questions during the show, you can use the hashtag on Twitter, Asteroid Day Icarus. and we'll try and answer your questions as best we can live on air. Now, that hashtag actually gives you a hint at what our live images from the Canary Islands will show, and that is the near-Earth asteroid Icarus. So look out for those images. We're waiting for them to be downloaded from the telescopes, and we'll bring them live when we get them live from the Canary Islands. But before we do that, I want to introduce a great friend of Slooh's. That is Slooh astronomer Bob Berman, the author of Zoom, How Everything Moves. Bob, great to be speaking to you this evening.
It's great to be here, Will. Fabulous.
It's an exciting day, I guess, because there's been so much talk about Asteroid Day on Twitter, on social media, also in the press as well. But to you, what does Asteroid Day mean?
Well, it's about time we raised public awareness of these things. As you mentioned, we got clobbered over a century ago, and just 2 years ago, on February 15th, a number of people were injured by incoming material. 1,000 people were injured. So we need to pay attention to them. And they range in fascination from an object you could see with your naked eye, Vesta, to bodies that pass very close to us, and Icarus is one of them. And, we don't have names for other celestial objects, like there's no Sun Day, is there? Oh, maybe there is,
No.
actually. Or what about Moon Day? Well, I guess there's a Monday also. So why not an Asteroid Day when we really focus on these objects? Overdue, I think.
Yeah, and it's difficult, I guess. The main thing I think's most interesting is trying to sort of quantify that risk, isn't it? Because of course we really want to go out and search the solar system for all of these asteroids, and we know of thousands already. But how likely is it that we're going to be hit by an asteroid, in the next 10, 100 years? Do we have any ideas?
Yes, and it's always a matter of how big, because every meteorite in everyone's collection, there's 50,000 known meteorites, and almost all of them, all but 88, were asteroids. So we do get hit every single night. And the question is, how large an object are we talking about? The only one really hurt by one that we know of was Simon Simonov. That was the man who was sitting on a rocking chair in the Tunguska region on June 30th, 1908, when bam, he got slammed by, it was dozens of miles away, but it was enough to be so bright in the sky that it actually gave him a burn on his skin and knocked him from his chair, and winds rolled by and knocked over trees for 50 miles in all directions. Look at this. And this was, by the way, not even seen until over 10 years later, when they finally sent a party to check out what had happened. These were turbulent times, of course, around the Russian Revolution. So scientists didn't even get there until later. And yet, look at this, over 10 years later, this was the 1920s, you could still see all the trees pointing radially away from that spot, really spooky and freaky and eerie from where it had burst overhead. So, yeah, it's a real danger. But the question is, in our lifetimes, what is the real hazard? And nobody's quite sure, but to be on the safe side, wouldn't it be a good idea to at least keep track of them, the ones that are hazardous, the ones that can cross our orbit, and to know where they are? We're doing that more and more. And perhaps devise a way to change their orbits. We can't do that currently. If we found one and we knew it was going to hit us in a week, there's not a thing we could do. So that's the talk. Should we change that? Should we be prepared?
I think this image that we have on screen really sort of brings home that point, is that we have found all these asteroids, and we've mapped quite a few of them. But actually, what do we know about where they actually come from? I mean, we know we have a sort of idea of how the planets form, but what about the asteroids?
Yeah, that's a whole other story. At one time we thought, well, the comets, they came from a sphere, the Oort cloud, and then got repositioned into the Kuiper belt along the Earth's plane. Asteroids were thought to be leftover planetesimals, left over from the creation of the solar system, almost entirely between the orbits of Mars and Jupiter, where Jupiter's mighty gravity, it's 318 times more massive than Earth. So no planet could form there. And these globs of material that successfully formed planets elsewhere, they couldn't come together. They'd be ripped apart by tidal forces. So instead you ended up with chunks of rock these hit other chunks. And so these days you end up with some 600 miles or 1,000 kilometers across. We're talking about Ceres, the only really perfectly spherical one, and others a few hundred miles across. And then they get smaller and smaller and smaller until now we know of thousands of them. Thousands of them are charted. And look at them. Look what we're seeing here, a range of sizes, and some of them have been perturbed both by Jupiter's gravity and by crashing into each other into orbits that really do cross our own. So there's a hazard. So is it a hazard equal to high blood pressure? Should we worry about that, like high cholesterol? Or is this something that's way off in the future and maybe to keep in the back of our minds, but nothing to really worry about? And the truth probably lies somewhere in between. And that's, I know, what we're going to be talking about tonight on Asteroid Day.
I think this diagram really sort of highlights something that you actually mentioned, and that's the huge variety in shapes and sizes, but also in some ways composition. Because although we're talking about Asteroid Day, there's a huge variation among the asteroids themselves, isn't there?
Oh yes, so correct. When we first found them on the opening day of the 19th century, very interesting, and we thought they were planets, new planets, until we found more and more of them: Ceres, Pallas, Vesta, Juno, and then as we got to see their composition, sure, some of them are mostly nickel and iron, some of them are mostly stony, some have carbon compounds, that is, organic compounds, the carbonaceous chondrites and others. And we see this just from our collections of meteorites. You can go to the nearby museum, they have them on display, and you can see what a range of materials that they're made of and a range of sizes and shapes. And when you're talking about thousands of objects, even though they have in common that they're not generally icy the way comets are, they're not generally, except for Ceres, round the way planets are. So they do have commonalities. They are mostly between Mars and Jupiter. They are mostly in sort of the same plane of the solar system as the planets orbit. They're not in wildly crazy orbits the way comets are, that can come at us from any direction and almost any speed. They generally stay in the plane of the solar system and orbit in the same direction we do. So by and large, asteroids on average hit us, when they do strike us, at lower speeds than comets, but they can make up for that with plenty of material, plenty of mass, and as you well know, the kinetic energy, or the impact damage that an object can do, is its mass times its velocity squared. So speed is very, very important, and that's why each one is different and offers a different hazard, all depending on its size and its speed.
Well, we'll talk about exactly what an asteroid can do when it hits the Earth, but I've just been told that we actually do have our first live images of Icarus from the Canary Lines, and there it is. Helpfully pointed out by the great cosmic hand there, sort of pointing it out on screen. But there we go. There are live images of this asteroid, and Bob, this is a sort of typical image taken through a sort of powerful telescope with a CCD camera, isn't it? We can't expect to see details like space probes see, can we?
No, we can't. And they really vary. They're all over the place. Many of our Slooh members are asteroid hunters and fanciers and take a series of images showing the motion of a particular asteroid. And especially if it's a hazardous asteroid, one that can pass near our orbit, boy, it can move awfully fast because, of course, closer objects tend to look faster moving than objects that are farther away. And then you get to the big ones that are all safely in the distance. Only one is the naked eye, Vesta. I know you're a great and famous observer in England. Of course, you're in England, so when do you get to see the sky? But when you can, I wonder if you've ever seen Vesta, the only asteroid that really can be seen naked eye. And Vesta is vanilla colored. It's the only really white, shiny, bright one. Most of them are kind of murky and dark, and making it even harder to observe is their low reflectivity, or albedo. Some of them are almost as black as coal.
You said actually when you were talking about a previous Slooh show that we saw them racing across, and I wonder if our producer can bring in a fantastic animation we had of a recent Icarus show, because we actually observed Icarus when it made its real close approach not long ago. You can see there back on the 16th of June, and there it is. Look at it zipping across the sky. So,
Oh, that's
if there
so
are any
cool, isn't it? That's so cool. And these are Slooh members who are doing this. This is our own Slooh
Absolutely.
telescope, and it's great. The members decide, hey, we want to see Icarus, and they take a bunch of images and put them together, and there it is, passing by us in the night, even with a distant galaxy behind it. Very cool stuff.
And this highlights a great point about Slooh, is that we've actually partnered with NASA last year, in fact, as part of their Asteroid Grand Challenge to sort of provide this data, because this imagery data is not just, it's not just a pretty picture of an asteroid zipping across. It can actually be used for science, can't it, Bob?
Oh, totally. And we can measure it. We can even see changes in its light using photometric means. We can tell if it's irregularly shaped and its size, and get all sorts of estimates. You can't see this kind of motion in the sky, although in 2027, if I remember right, we're going to have Apophis moving so fast on a Friday the 13th, April 13th of that year, that it actually will be a naked eye object moving fast enough for you to actually see it, third magnitude, as it swings by in the night sky. But that's really rare and extra scary when you have one that's only passing about as close to us as our own geostationary Earth satellites, as will be the case then. At least we think that will be the next time something will come that close. That's the whole point of Asteroid Day, is increasing our awareness so that if one does, we'll know about it ahead of time. And the only way to do that is to keep observing. That's what we're doing here at Slooh. But one of the big issues is, how do we raise public awareness and get more people on board with the asteroid thing without making them unduly paranoid? We don't want to, say, hey, the world is ending, but it's kind of fun. It's cool stuff. So it kind of combines paranoia with astronomy.
As we watch these live images, any keen viewers, keep an eye on that little dot just off the right of center there, and hopefully during the show we'll be able to see it tracking against the background stars. There we go. There's the cosmic hand again coming in to point it out. But Bob, you said something earlier, and we were going to talk about it. You began to sort of talk about the sort of destruction that an asteroid can cause. What sort of things, let's say, if we were really unfortunate, perhaps in 100 years' time, an asteroid's discovered, it's on a collision course. What sort of damage can these things do to Earth? I mean, Earth is huge, isn't it, compared to them?
It is, but let's take the example. Well, hey, we have a picture up. Let's use this example. This was the Barringer crater, now called Meteor Crater, in Arizona. And here's an object that was only perhaps 1/10 this size when it came in. But look how it makes a crater almost a mile across, disproportionate to its actual size. And that is, again, that kinetic energy has to go somewhere. So if the object is massive enough and fast enough, this is what will happen. Quite lovely. You see the raised rim, just as we have in lunar craters. And we see some of these on Earth. Maybe one of the most famous is the Chicxulub crater, mostly buried under the sea off the coast of Mexico, the Yucatan Peninsula, one of the raptors' favorite beaches there back in the age of the dinosaurs. And we're talking about 65 million years ago, when they sure didn't see it coming. And there was an event, probably an asteroid, that destroyed a good percentage of the genera on Earth. Not only ended the dinosaurs, but allowed us mammals, to take hold. And rats, starting at first with rats and other mammals, saw their ascendancy till now. We're in the age of, rodents and sitcoms and things like that wouldn't be here had it not been for that impact at the boundary between the Cretaceous and tertiary period. So there it is. And look at this one right here in America at the near Barringer, Arizona. So yeah, we definitely see tremendous impacts. And Will, you brought up the event on June 30th, 1908, of which this is the anniversary. And there was one that did not even have to hit the ground. And that's the
No, it's
point.
like an airburst, wasn't it?
Exactly. And
Mm.
if it doesn't make it to the ground and bursts in the air, as recently happened on February 15th of 2013 and happened a little over a century ago, it'll still do this kind of damage. Now, if all these sturdy trees for 50 miles in all directions were snapped off and blown down radially from a spot directly below where this thing blew up and scorched this poor man's chest with heat burns, even though he was dozens of miles from it, what would that do to property values in our modern, much more crowded age today? I mean, that was over a part of Siberia with very low property values. Essentially, nobody was living there. But imagine if this same event that we're looking at now occurred over any kind of urban area in the world today. And you know, we don't even have to say any more about it. It just becomes obvious that if that could happen a mere century ago, it could happen again. So without being alarmist, sure, it does seem like we should be at least watching and monitoring them. Sometimes they come from the sun's direction, and we don't have much of a shot at seeing them. They're in the daytime sky, and they're coming right at us. That's what essentially happened 2 years ago. But with a little bit more time and attention, we could certainly catch a lot more of the ones that we don't know about.
Well, I know that there's lots to talk about this, and I know, Bob, I'm going to be coming back and speaking with you later. But for now, thanks for speaking to me about this. I want to talk to you later because I think there's two sides to this story about asteroids, and I think we'll pick that up later on in the show. But for now, thanks very much, and I'm going to be speaking next to
Pleasure.
none other than private astronaut Richard Garriott, who's one of the signatories on the 100X declaration, which is an Asteroid Day declaration. And, you know, this will be an opportunity for you to ask questions as well. So if you're watching live on Twitter, use the hashtag Asteroid Day Icarus. And if you've got questions for Richard, we can bring them in and hopefully ask him your question live. But as you can see, this whole story of asteroids goes back, you know, centuries. In this case, we're celebrating the 107th anniversary of the Tunguska event today. But of course, it's a long story, and one that even goes into our future as well. And that's something that I really want to discuss with Bob afterwards. But I believe now we can speak to Richard, who's just joining us on Skype. Not just yet, he's coming in. Hopefully we can, maybe we can bring back those live images of Icarus that we had earlier, if we can bring them back on screen and see if that's moved at all. So let's see if we can find Icarus on the screen. This is essentially what astronomers have been doing for decades, even centuries, is looking at tiny little dots and watching as one moves to try and track its motions and track its orbit. But you'd have to have a very keen eye to actually watch it. And of course, this is something that this is how the planet Pluto, was discovered with what's known as a blink comparator. So sort of flashing back between two different images taken on different nights and seeing how the object moves. But hopefully we can speak to Richard. It doesn't look like we're able to bring in Richard at the moment. We've got this animation from a previous if we can go back to the animation from the previous Icarus pass, we had an Icarus show just a few weeks ago, actually. And you'd be able to see what it looks like when you speed things up. So this is what we see through our Slooh telescopes. And of course, as Bob was saying earlier on the show, one of the things we're really doing here at Slooh is using the telescopes to basically capture different types of data. So there's what we call astrometric data, which is data about the position of the asteroid against the background star fields. If you're a Slooh member, you can come join us in the clubhouse, and there's a fantastic team of astronomers there called the A team, and they basically do amazing work charting the position of all sorts of what we call minor planets, these near-Earth objects, near-Earth asteroids. So it's not just the positions, but also what we call photometry. So essentially measuring the magnitude, the brightness of the little dot, and that can tell you all sorts about the particular object. So you know, if it's spinning, you can see changes in the brightness, and all these things. It's incredible, really, what you can sort of get out of observing a little dot moving against that background star field. But as I say, we are trying to get Richard Garriott live here for you. If you've got any questions, I'll just get on Twitter and check and see if there are any questions using the hashtag Asteroid Day Icarus. But if not, hopefully very shortly we'll be able to bring in Richard live. Perhaps while we're waiting, we can go back. Here we go. What's that? So we've got a question here. Perhaps this is one I can talk with Bob later, but the question seems to be, is the technology for deflecting a near-Earth asteroid perfected enough that we may use it if an asteroid came close in the next 5 years? And that's an interesting question, maybe one that we can talk with Richard about. My personal view is actually we don't have a lot of options at the moment. The main thing, I guess, is probably something like a nuclear warhead. Of course, there are all sorts of other ideas, but most of them, I think, are probably really science fiction. So you've got ideas like everything ranging from what we call a gravity tractor, which is essentially parking a very massive spacecraft right next to an asteroid and using the gravity of your spacecraft to sort of perturb the orbit of the asteroid enough to deflect it away from the Earth. Then there are all these sort of ideas of attaching something like rocket thrusters to push it away, because you don't actually need to move the asteroid that much. You just need to deflect it out of the way just that little bit, just so it gets out of the way of the path of the Earth. And here's another idea. This is another sort of NASA prototype idea using sort of one possible idea is you could essentially attach a giant solar sail. So much like you might have seen the Planetary Society testing their fantastic light sail, this would be attach an enormous sort of mylar foil-like sail and allow the radiation pressure, the sort of pressure from sunlight falling on the foil, to sort of push the asteroid and perturb it. So all these kind of ideas, I wonder, it's a great question from Twitter. I wonder if we discovered an asteroid, maybe that would provide the impetus to get people thinking about really building these technologies. But my personal view is that actually we probably at the moment have to resort to fairly conventional things. But it's an interesting, a really interesting question. We've got some more animations coming through actually that we can give you an idea and show you what some of this asteroid data looks like. So there's another asteroid zipping across the field of view, and this is something that actually even amateur astronomers with quite modest telescopes can do. So if you've got a CCD camera or maybe a DSLR camera, something like that, somewhere where you could open the shutter for at least say 10 to 20 seconds, you should be able to pick up asteroids moving across the background star fields. One thing you will need is what we call a tracking mount. So this is a mount that has been set up and aligned to the night sky so that it's essentially tracking the motion of the stars, and that will allow you to get a sharp image essentially. Otherwise the stars tend to blur. But this sort of thing is well within the realms of amateur astronomers, and I know I want to talk in much more detail with Bob later on about what's how amateurs can do that. But this actual asteroid you're seeing here is one called 2004 BL86. And if my memory serves me right, I can't remember, but I think that cluster of stars there is the Beehive cluster, Praesepe, Messier 44. So that shape of stars in the middle, that sort of triangular shape, it seems to sort of look slightly familiar to me. So this is one of the interesting things. Sometimes astrophotographers capture asteroids completely randomly. And you just see these little streaks moving across the background star field. So we're going to bring Bob back in now. We're having a little bit of trouble getting hold of Richard, but Bob, we've got this fantastic question from Twitter, and they're using the hashtag Asteroid Day Icarus. And the question is, how close would an identified asteroid have to come to Earth before people would start to worry? Where would you start to worry, Bob?
Oh, me, only if it was going to really hit us. For example, we have an identified asteroid, again, Apophis, coming close to us. I believe it's 2026 or 2027, April 13th. Funny how I'm sure of the date and even the day of the week. It's a Friday, but not the year. So we know that's going to happen. We know it's only going to be about 22,000 miles high, plus or minus only about 500 miles. And I'm not worried. We might be a little bit worried about 5 or 6 years later on its next pass to Earth because its orbit could be changed by that one. I believe the latest odds are one chance in 250,000 that it would hit us on that second time. That's pretty low. Wouldn't worry about that either. But other people, well, there's people who are worried about imaginary things like that that supposed planet that's wandering closer to us, nigiri, something like that, or is that a fish
Oh
dish, a
yeah.
raw fish dish? Um, but there, if you look on the internet, you'll see people worrying about all sorts of cosmic threats that are either extremely low probability or don't exist at all. So, you can't say before people would start to worry. Fortunately, we're pretty good at this. Once you have a few images of the item, you can calculate an orbit very accurately. And with these things, it's either uh, a miss or not a miss. And a close call, like the one that we're going to get in only about a dozen years from now, doesn't count at all. It's, a miss is as good as a mile or a kilometer in your case. But uh, it's the ones you don't know worry about. It's the unknown ones. That's the thing, and that's part of what Asteroid Day is about. So that there are fewer unidentified, unknown objects out there. That's, I think, the key.
One of the things we were talking about before I said goodbye to you, and I think this is it's kind of like a flip side to the discussion we're having, is you said something very interesting about how the sort of chain of events of that particular impact allowed us to be here. And I think that is also the sort of flip side of the asteroid coin, isn't it? It's because they can be destructive events, but also if we believe, all what planetary scientists believe about the formation of Earth and how we got things like our water, they're also very, very important to us, aren't they?
Well, they sure were in the past, yes. And there is a chance that comets, in particular, and perhaps asteroids, which are now thought to perhaps have more water than we once thought, could have even brought us our oceans. But now that we have our water and our oceans, I think we'd rather only see the little ones flashing by, as we do 6 per hour on any clear night. We see a combination of asteroid fragments and comet fragments in the form of those beautiful shooting stars or falling stars or meteors, especially coming up. I know we'll be covering it here at Slooh, the great summer Perseid meteor shower, 2 nights this year on August 11th and on August 12th. Should be the best in years because the moon will be absent. So we do want to see some, but
Mm.
preferably small ones.
There's always that thrill of seeing a sort of an Earth grazing meteor or a particularly bright fireball, isn't it? But I think I have to agree with you. I'm fine with meteor showers, but I don't want to see anything particularly big.
Yes, 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 exactly. So
Now,
go ahead. I'm sorry.
oh, sorry. No, I was going to say one of the things we started talking about earlier on was actually what damage an asteroid can do when it hits Earth, and we talked briefly about the sort of meteor crater and that beautiful sort of structure itself. I mean, these craters, they have a very sort of defined shape. Is that caused by the asteroid shape, or is there something else going on here?
No, the shape of the asteroid is irrelevant. It's really the impact forces, the kinetic energy that is distributed pretty symmetrically in all directions from the impact. So, what often happens, and did happen here with this particular crater, is that there's little or no asteroid material left. The meteoroid gets pulverized. Some of it actually gets vaporized, but what's left gets mixed in with the soil, and you're lucky indeed if you can find fragments. Sometimes you can. But very often the impact is so huge. You can imagine the kind of energy to create this kind of hole almost a mile wide and to push up that surrounding ridge. We see these beautifully on the moon, typically 60 miles, 70 miles across. Our lovely examples, Copernicus and Aristarchus and all the others on the moon. But we see them happening here on Earth. If you ever get a chance, Will, if you haven't already, go on out there. It's quite something to stand on the
Uh,
rim of this meteor crater and gaze across. And Again, think about
I'd
what could
love to
happen.
visit.
This probably would not have stood the test of time. I believe it was about 50,000 years ago that it struck Earth, but thanks to that dry area, it's been preserved much better than a similar impact, let's say in the tropics, would have. And of course, Earth is mostly oceans, and if it happens there, there is no discernible trace unless it disturbs the seabed, as we have in the Chicxulub example off the Yucatan coast.
Okay, well, it's been great speaking to you again, Bob. We're going to try and bring Richard back in now because we think we've got him on the line. And I'll catch up with you later, Bob, and we'll talk in
Okay.
more detail about what amateurs can do to help this Asteroid Day effort and raising awareness. But yes, as I say, we on the line we now have Richard Garrett, of course, one of the signatories on the 100X declaration for Asteroid Day, and one of the things I no doubt we'll be talking to him about is exactly what it is, this particular declaration. Richard, thank you so much for joining us.
Absolutely, my pleasure. Glad we managed to connect there.
Yeah, it's great to have you on the show. So, I mean, you've been to space. You've sort of looked back at Earth and seen this, you know, what Carl Sagan famously called the blue marble. Did it change your perspective on our home planet?
Yeah, unquestionably. You know, there's a term that I had never heard prior to my flight, but I now I experienced something called the overview effect, which is a term commonly given to people, the people who have this experience that where, you know, when you are in orbit around the Earth, it's like there's a fire hose of information about the Earth kind of just pouring into your mind. You know, you see a sun, you know, you're going around the Earth at 17,000 miles an hour. That means you go all the way around every hour and a half. You see a sunrise or a sunset every 45 minutes. You cover entire continents in maybe 15 minutes. And it's like a fire hose of the truth of the world kind of pouring into your mind just as you look out the window at the beautiful Earth below you. And as magnificent as that view is, it takes a few days actually before most people describe this event called the overview effect, where they sort of, after a while, kind of go like, you know, I kind of get it. I understand weather and tectonic plate movement and erosion by wind and water, the impact of humanity. And then especially after you've been around a few times and then you see a place that you know well, and in my case, it was near where I am now, the Texas Gulf Coast, an area that I've driven and biked and ran, you know, a lot. And you can see the whole world you've now been around a few dozen times. And suddenly you have this physical reaction where you go, wow, I now know the true scale of the Earth by direct observation. And it definitely, you know, I would have described myself as an environmentalist before, but afterwards, you know, my interest in being a good steward definitely shot up, you know, quite a bit.
Well, that's the thing, isn't it? I've read a lot of sort of the writings of the Apollo astronauts, and they all seem to say, or at least a common thread amongst them, is that looking back at the Earth, it seems so fragile. Was that a sort of maybe something that got you interested in Asteroid Day? You know, that sort of perspective that you got?
Well, they're definitely related. I mean, I was interested, frankly, before my flight, but it
Yeah.
also because you know statistically, I was already well aware of the importance of this issue. But there's no question that you know prior to my flight, while I would you know self-describe as an environmentalist and somebody who really cared about the planet, you know, since my flight. I kind of I walk the walk a lot more than I just talk the talk, and I've become much more heavily involved in initiatives like this, and especially with asteroids, you know, it's inevitably, you know, whether you're talking about, you know, car wrecks or asteroid impacts, you know, it's never the thing you expect to see coming that hits you. It's always the one you're not planning for, that you're not paying attention. You know, it's when you're not paying attention to driving is, you know, when people have a car wreck, usually close to their home. Well, the same thing's true with asteroids. We know for a fact they are statistically, you know, not uncommon, that there will be, you know, with you know, predictable frequency, things that will be meaningful to have impacted the Earth, damaging to cities or more if they were to hit the Earth. We know that frequency, and yet that frequency is just low enough. It's just long enough compared to a human lifespan that it's very easy to forget about it and not realize that There's still plenty of big rocks out there that not only very likely could, but frankly will impact the surface of the Earth, within the predictable future.
I think that's perhaps the most interesting part of it. Is there's almost a sort of human psychology element to this preparedness, isn't there? Is because we've got to sort of plan for long past when we're gone, essentially.
Yes, although while an extinction event level asteroid is only once every significant number of millions of years apart, things that could do enough damage to take out a city, or when I say take out, I mean be impactful to life in an important way, something important enough to take seriously and consider whether we should deflect it or in some other way deal with it, prepare for it in some way. The interesting thing about that is that those are most of those asteroids are ones that we have the technology at hand right now to go out and find, to track well, and even to deal with, given sufficient lead time. One of my favorites to talk about as a hypothetical that we are safe from, but makes a good illustrative point, is the asteroid Apophis, which is actually going to make two very near passes well within our lifetimes. So close, so close, much closer to the Earth than say the Moon, to where the orbit of Apophis will be bent around the Earth as it wheels around the Earth. And while we know with good reliability that one will miss us, it's also of the class that would do a lot of damage if it would have hit us, and is one that we probably could deal with, given the amount of time we know in advance that it's going to come by. If we really wanted to deflect its trajectory sufficiently to make sure it did not impact the Earth, it's one we probably could deal with within the decades or two that we have to go take care of that. And so that's really what stage one is. What we really need to do now, and what we're doing right this moment as we talk, is just build awareness. Just have people let people know that this is something that, though it seems rare, is something that we're going to see likely within our lifetimes. That is something we can deal with, and all we need to do to make sure that we are prepared is look. And so just getting people on board with let's make sure we've searched to make sure we know where all the big ones are. We already know where most of the big ones are, but let's finish that survey to where we can say with good confidence that there's not something quite large lurking that will hit us within a decade or less.
I think that's really interesting, because there is two parts, isn't there? Is that actually discovering the asteroid in the first place, which is almost as big a challenge in some respects as the actual deflecting it and going about doing that. Do you think we are doing enough in terms of searching for asteroids and actually looking for these potentially dangerous ones?
Well, there's sort of a two-tier problem. To find 90% of things that we should be concerned about is relatively easy, and in fact is underway now, and can even be aided by amateurs who are looking with their telescopes, and the large professional observatories, with every survey they do for almost any kind of photography, amateurs can go behind and look for the evidence of asteroid movement in those photographs. And that works for a large percentage of the asteroids. The problem with that method is that there's 5 or 10% of existing asteroids that the only way to have seen them would be to look in a direction that really requires you to look directly forward or aft of the direction of the travel of the Earth, such that the sun's light actually becomes problematic to see things that are in that particular plane. And so there's one very important swath of asteroids that are very hard to detect from here on the surface of the Earth. And so to pick up that last tranche, we really need to do something a little bit more concerted. There's a variety of proposals for things like putting even a modest telescope in orbit that could get away from the angle problem that we have to find them, and therefore could survey from a better location to see that last tranche of asteroids. So, and these are all things, and even on terrestrially, there's ways that if you put enough data together, you can still search those bands. And there's groups like the B612 guys that are, trying to, get even terrestrial telescopes built that can help search that last band.
Do you think that you mentioned there about the B612? Do you think those sort of efforts, including other ones like the sort of crowd-funded efforts to launch these telescopes, is that the way to go? Do you think for this particular type of surveying?
Well, the good news is fortunately these kind of surveys don't require a Hubble Space Telescope or these multi-billion-dollar efforts, and so whether it's the crowd-funded groups or B612, both of those are quite viable. It really, that's why this first step really is just awareness and let's go look. The price tag is not particularly hefty. It's something that crowdfunding or small companies, amateurs could easily be significant contributors to. Once we identify something that we think might be a problem, then we actually did the second phase of that, which is deflecting an asteroid. That would be a much bigger cost, a much bigger effort. But by the way, once we have any reason to believe that there's actually something going to hit us in 10 or 20 years, or whatever the predicted time frame is, I assure you, all the governments of Earth, much less those that would be impacted, will quickly find the funds to help put the process together to mitigate that risk.
It seems to me that a lot of these surveying efforts, part of it is that sort of sifting through the data and looking, just like these live images from the Canary Islands, looking for those little dots moving against the background. Is that something, with your experience in sort of developing games and things like that, do you think that through citizen science we could sort of gamify and sort of get people discovering asteroids en masse?
Absolutely. In fact, there's already some efforts, underway to do that. A lot of observatories make their data available so that amateurs can do that searching. And in fact, some of them even help improve AI searches by kind of a combination of human and computer aided design. So you can actually go through a training process, learn to be a good observer, be graded by the AI, and then move into a status where you actually now are operating independent of the AI to double check the AI, and then ultimately help improve the AI to know what to look for. And so, I've gone through a few of those training exercises myself. They're, the first steps are easy to take, but of course, we're talking about something now. You're talking about very faint objects that are very distant, very subtle in a photographic plate. It does actually take a good eye, but there's no question that gamifying it is a great idea and is underway now, and I think is already proving, honestly, to be a big part of the solution to this problem.
It's been fascinating to talk to you, Richard. Thank you so much for coming on to Slooh and giving us your perspective. We wish you all the best of luck with Asteroid Day, and we're going to say goodbye now. And I'm going to bring back Bob Berman, who is our Slooh astronomer, and we've got these live images from the Canary Islands, and this is a near-Earth asteroid, Icarus, on screen live now. But we'll be bringing Bob just in a few minutes to talk about some of the things that Richard touched on in his discussion. One of the things that we always like to do here on Slooh is get questions from you live to talk to our experts. So if you do have a question that you want to ask Bob, or perhaps Duncan Kopp, who's coming up in just a few minutes. He's a film director and producer. He's produced things like In the Shadow of the Moon, that fantastic moon documentary. So maybe you've got a question for him. Bob, it's great to have you back and be back talking to you.
Thank you, Will.
One of the things I was talking about with Richard was the fact that amateurs, they can actually contribute to this science field, can't they? It's really something that, someone in their back garden can do with a telescope and a reasonably good camera. They can actually submit their data.
Yes. This is a place where all eyes on deck. The more people we have watching, the better. The amateur, of course, needs a little bit of knowledge to be able to recognize objects, find them, but there are organizations that do this. And yeah, we'd be on for hours if we were to list all the contributions of backyard amateurs to astronomy over the years and over the centuries.
I know it's actually something that the A team in the clubhouse here on Slooh, they've actually done, haven't they? So they regularly submit their data to the Minor Planet Center, and that allows astronomers to essentially refine orbits and things like that, right?
Yes, absolutely, and it's great. I mean, these are people. I mean, that instead of watching daytime TV, not to put anyone down, are actually doing serious science and using the instruments that we have here at Slooh, which are pretty darn good. I wish I
Mm.
had this. A few years ago myself, especially for people who are in cities and who are in light polluted environs, where no matter what kind of telescope you have, you're not going to be able to see very much. So it's great that Slooh supplies the instrumentation and the perfect dark sight so that you can actually do this stuff. The Canary Islands is one of the better astronomical places in the world. Look at that asteroid going by. That's Icarus, isn't it? On our last flyby, which wasn't too long ago, was it?
No, just a few days ago, in fact. And
Yes.
what if I was to go out tonight with a large telescope and try and track down one of these asteroids? Would I actually see anything? What would it look like?
Well, it would just look like a dot. If you can get out, and this is, of course, for everybody who has clear skies, please do so as soon as darkness starts to wane a little bit. In other words, in twilight, because tonight, and to a lesser extent tomorrow night as well, we're going to have this amazing conjunction between Jupiter and Venus, the brightest conjunction of the year. That's tonight. The two have been approaching each other and approaching each other. So as long as we're talking about solar system objects, there are two. I won't say of the brightest. They are the brightest. The two brightest star-like objects in the sky meeting right near the star Regulus in Leo, and that's for all of you. If you have clear skies, just look in the direction of sunset. Say about 45 minutes after the sun goes down tonight, and or join us tomorrow night when we're going to
Mm.
be bringing that also. We're going to be looking at that close up. So sure, lots to do.
Yeah, absolutely. If you don't have clear skies, we will have a special show all about the Venus and Jupiter conjunction, which, as Bob says, is going on right now. An absolutely beautiful conjunction. But we will have live images tomorrow night in a special Clubhouse clip. That's just for Slooh members. So come and join us on the Slooh Clubhouse, and you'll be able to see the live images from the Canary Islands of that particular conjunction, just like we have live images here from the Canary Islands of Icarus. And I don't know if there's any keen-eyed viewers who've actually managed to see it. I haven't been paying enough attention to the actual star field and seeing. It's quite a skill actually noticing it moving, isn't it, Bob?
It is, and this is, of course, a live view. That's the great thing about Slooh. I've been with Slooh for over 10 years now, and I still never get tired of it. That here is the universe in real time, live. This is how it looks right now. And some of you are in daytime at the moment. I am, and so you're thinking, hey, how come the stars are out? Because the Earth is curved, and someplace on Earth it's always going to be starry. Which reminds me of a question someone actually once asked from an audience during a talk. They said, if the sun is a star, why can't we see it at night? So anyway, here's the answer to that. As we look here at Slooh, where we are seeing suns, distant suns.
Distant ones. Well, that's actually all from me. I'm going to disappear for a moment whilst I hand you over to chat with Duncan Kopp, who's a film director and producer. He's a producer, as I said earlier, in The Shadow of the Moon. And Bob and Duncan are going to talk a little bit about asteroids in popular culture and how they've been represented, and some of those interesting topics from Asteroid Day 2015. So I'll say goodbye for a very brief time and hand you over to Duncan and Bob.
Good, good. Well, this is great. Duncan is We have him on here at Slooh from time to time, and when Will says he's going to hand him over, he doesn't have to hand him very far because these are fellow residents of the British Islands. So the British Isles. And so we don't have to go too far. Same time zone, prime meridian, to talk to Duncan. And as we'll see, he produced that famous award-winning In the Shadow of the Moon that brought up the Apollo program, and he's interviewed every one of the people who've walked on the moon. So do we have him here yet? Do we have Duncan all ready to appear on our live screen? Let's see. Right now he's looking very dark. There's a box that says
I can hear you,
Cup.
Bob.
And we can hear him. So perhaps we should proceed.
I don't know whether you can see
you.
me, but I can see you and I can hear you. It's good to see you again.
And the same. I can't say I can see you because you look like a black box, but perhaps our people at home can see you. So let me assume at least we've got the audio, and maybe we have the video, the live thing as well. How are you, my friend? How are you doing there?
I'm very well, thank you. Yeah, good. Good to hear you. How are you, Bob?
Great. I'm fine here. I wish we had clear skies for this great conjunction of Jupiter and Venus here. I hope you're doing better from the British Isles, but right now, and there you are. See you just fine. And
here I am.
Okay, there you are. Yes, and looking younger than ever. This is very good. You
Sure
know how to live.
that.
Obviously, you're living very well. So we've talked in the past, of course, about Venus, which I happen to know. I happen to have the secret inside gossip that this is what you got your degree in astronomy. Duncan doesn't boast about this, but he has a doctorate. This is Dr. Kopp, doctorate in astronomy. His specialty was Venus. Venus, of course, is tonight is meeting Jupiter. The whole world is watching this spectacular conjunction. We've talked about the moon because Duncan's award-winning documentary In the Shadow of the Moon explores the manned missions to the moon. But tonight we're going to talk about asteroids. And I have to ask you, because I don't know the answer to this, what's your connection with asteroids? Do you care about them on Asteroid Day today? In what way do they resonate with you?
Well, that's an interesting question because I think, my experience of asteroids really would be Vesta and Ceres, which are the two sort of brightest asteroids that I remember seeing as a boy when I was interested in astronomy. And I have to say, when I saw them, I was a little underwhelmed. And I think that's the interesting thing with asteroids is they seem to be really quite underwhelming when we study them from Earth through a telescope. But in fact, they're sort of a double-edged sword because they're so important in many, many ways. And obviously, one of the most important ways that we've come to learn, relatively recently with planetary geology and astronomy is we're at risk from asteroids. There are far more asteroids than we ever thought there were. And in fact, we've only probably detected about 1% of all the 1 million asteroids that we think are out there. Something like 10,000 that we've tracked.
That's worrisome.
Well, I think it is. I think it's very worrisome. And I think what's quite interesting for me is, as a boy, I was a bit nonplussed with asteroids. But now, having studied a little and learned more about them, you realize just how important they are, not just from an impact point of view, which is obviously critical, but also what they may tell us about the early formation of the solar system, because they're sort of postcards from the past, they're pristine bits of rock, but also where they may lead us. Quite literally, they could be the stepping stones to get us to Mars, because if we are to go to Mars, we can use asteroids in many ways to practice lots of maneuvers, lots of sampling techniques, lots of rendezvous techniques. And I know that NASA have some really exciting missions in the pipeline. But I think first and foremost, it's getting a grip, a hold on just how salient they are from point of view of whether we can ever be hit by one. And we know we can, because on this day in 1908 was the big Tunguska event, where we got hit by, some say a comet, some say an asteroid, but a bolide, an object from outer space. And that wasn't a particularly big object. I think it was about 40 meters across or something like that. But it did a lot of damage. I mean, the pictures you're showing now show the trees that were knocked over thousands of square miles. And this was an air blast. This object disintegrated in the atmosphere. But if something like that were to happen over New York or Washington or London or Cape Town, Paris, it would annihilate those metropolitan areas. And of course, we should be aware of that. I think that's something we should think about, and we need to know more about these asteroids, how many they are in their paths. As I say, just the tip of the iceberg at the moment.
If that's the case and we only know 1%, what would you like us to do? What do you think we should do in terms of tech-wise or political climate-wise? What should we be doing, in your opinion?
Well, it's interesting, isn't it? Because I know there are a number of possible missions on the horizon. One is a private mission, actually run by an ex-astronaut called Ed Slooh, and he's got a mission, private mission called Sentinel. And the idea there is to send up a satellite that has an infrared camera, infrared telescope that's able to see these asteroids and detect these asteroids and map them. And it's interesting because I think the predictions are within the first sort of six months of that mission, I think they're hoping to discover something like 20,000 asteroids. And that's more asteroids than all the discoveries through all the telescopes on the Earth in the last 30 years. And therein lies the crux of the problem. We don't look for asteroids. We don't go out and look for them, because really we've never had the need to. But now we're understanding more that, in fact, what's potentially dangerous about all these asteroids, or at least not knowing where these asteroids are, is perhaps we can get hit by one. And of course, the chances are, if there were a large enough impact, you could have a tsunami. And with regards to the world's population, the majority of the world's population live in coastal areas. So that means a lot of people at risk.
Well, I was going to ask you whether you think we're prepared for the asteroid, the one with our name on it. But from the way you're talking, I think obviously you think we're not, right?
Correct. Yeah, no, Bob, I don't think we are. I mean, because it's one of these sort of literally out of sight, out of mind. And if you refer back to that statistic, if we only know of 1% of asteroids that we've tracked, it's about 10,000 that we know of and we've tracked, and we know whether they're going to hit Earth or not, how close they're going to come. Turn that figure around. 99% of the asteroids that are out there, we have no idea what their trajectory is, how big they are, when they may come close to Earth, whether they may hit Earth. And, that's quite a shocking statistic when you think about it. So I think more should be done to understand these particular asteroids. It's not difficult. This is not sort of blue sky thinking. It's relatively easy. NASA also have a proposed mission where they want to be able to detect near-Earth objects with a camera. And again, for a relatively small investment, we could quite quickly be able to get up to 99% of all these asteroids, given maybe mapping over a decade or something like that. I think that's a really good investment. And then, of course, there's a lot of science that can be done as well. But first and foremost, I think it's a pretty good idea to understand where these things are. And that's the irony, because, as I say, when I first read about asteroids and saw Ceres and Vesta, through a telescope, they look so inconsequential, but in fact they could have really big ramifications for us here on Earth.
All right. What do you say to the people who claim that you're right? Most of them aren't seen, but we have seen, because of all the surveys and such, we have mapped almost all, if not all, of the brighter and the larger ones, and it's only the small ones that we haven't seen. So we're talking about mainly we don't know about things in the maybe 40 meter, 20 meter, 10 meter class, especially, but these could still do plenty of damage, couldn't they?
Totally, absolutely, and that's the point. Again, Tunguska, 40 meters across. It's not particularly big. I mean, you really wouldn't want something like that exploding or having an airburst over a large conurbation or urban area. I mean, that could do a lot of damage. And I mean, if you think about it, even if it hit over somewhere like the Midwest or, Alberta, or somewhere where there's a vast area of wheat growing crops, you're going to have thousands of square miles of crops that could be devastated. I mean, that could have a big impact on us. So I think it's really important to try and understand these interlopers in a more refined way. So at least we know the statistics, because only then will we know what it is we have to do if we're faced with a circumstance where there could be one that's going to come and strike us. And it's that not knowing, it's almost like taking out an insurance policy. It may never happen, but at least you want to know that you're safeguarded against it if it does. And I think that's a good argument for these missions.
Okay, so let's say sold. I like everything you're saying. What do we do next? How do we stir up people? You're a filmmaker, so this brings up. What do you think about the way they're portrayed on film? I guess they're not portrayed on film very much. And what would you do to stir up, Mr. and Mrs. John Doe and Jane Smith and the people out there who never think about these things, to raise public awareness? This is Asteroid Day. This is the day that we can ask questions like that. What's next? You're a filmmaker. What would you do?
Well, I think Asteroid Day is a very good start. And I mean, there have been Hollywood films, haven't there? There's Deep Impact. I think that was a comet. But Armageddon is the classic one that most people remember. And okay, it's a little bit far-fetched. I don't think, well, if you think about it, we would never want to be in a position where we have to train 14, I think they were oil drillers that have to go and put a nuclear warhead on an asteroid, and they've only got 12 days to train them or something. The interesting thing is that's a situation we would never want to get ourselves into. So, there's some truism in the film in that obviously we know that asteroids can cause dangers, but what the films also highlight is, the kind of situation we would never want to be in.
You really remember that plot, don't you? You how many times did you see that film? You really remember the plot better than I do.
I saw it once, but it was out some time ago, so I don't remember. I think Bruce Willis heads the cast, but I can't remember. It was a long time ago.
That's right, and maybe Morgan Freeman, although he's in everything, isn't he? Yes, in fact, when we hear a documentary, it feels like life itself should be narrated by Morgan Freeman. If his voice isn't there, there's something missing, even in everyday life.
A wonderful voice. But you asked, how do we make people more aware? It's a very good question, and it's very difficult because it's almost jovial, isn't it? Oh, we could get struck by an asteroid. Oh, don't be silly. That's hardly going to happen. But, well, it is, because it has happened before, and it's had, huge consequences on the planet. I mean, the last relatively big impact didn't cause any deaths, but caused injury, was in February 2013 with the Chelyabinsk strike in Russia. And I think that was a pretty big reminder of what's out there. You never know when these things are going to strike. Okay, nobody was killed, but people were injured.
1,000 people.
And that I think had the impact power of between 20 and 30 Hiroshima atomic bombs. It was about 500 kilotons of energy. And that thing wasn't very big at all. You know, you're not, that's not a big, a couple of tens of meters across. Now, if something 40, 50, 60, 100 meters were to strike,
very scary. By the way, while you're speaking, we're showing everybody Slooh images of previous asteroids that have come by. Slooh members tracking various asteroids. We were just looking at 2013 WT67, if I remember correctly, and we're looking at you know, this is video. These are actual images that, you know, we never run out of them, of course, as the asteroids zoom by. Well, I hope you will make an asteroid movie. I love the things that you do, Duncan. Totally professional. You never let on that you're doctorate in astronomy. That always impresses me. But you know, your films are so good. It's almost like, who cares who did this? You know, because the results are so great. Thank you so much for coming on again, and you know, we always look forward to having you here at Slooh. It was just great. And thanks for helping us celebrate Asteroid Day here as we continue to look at asteroids live and other images. Thank you, Duncan. Yeah, and while we're watching, we're looking at tracks now of near-Earth asteroids. Now, these are the hazardous ones that can actually come into our orbit. Look at them. Look how many orbits have been plotted, and you look at that. And, of course, this is a 2D view, and you can't tell from this angle how many of them cross the plane of our orbit in 3 dimensions, but it's still enough, you know, that raises eyebrows and, you know, I don't know, makes me a little bit nervous. But Will is back. You're always the voice of reason, and you know, let's not be too alarmist. There's another side to it. Nobody's been killed by an asteroid yet. Only one person has been injured by a piece of an asteroid. By the way, that was Ann Hodges in Silicoga, Alabama in 1954, when a piece of an asteroid came through her roof and struck her on the upper part of her leg. Fortunately, didn't kill her, but she was the only person actually injured. So, you know, I guess you could make the argument, if no one's yet been killed, then maybe nobody ever will be. I don't know. What do you think?
I think, I mean, it's always difficult to say, isn't it? You know, an asteroid, like as we've discussed on this show, you know, they could be discovered very close to the sun, and then, you know, potentially we could have a Chelyabinsk style event over, you know, that's a little bit more damaging. And that I think is the smaller ones that I think, not these sort of extinction level events. They're of course much less likely. It's those ones that seem to come from nowhere, you know, come out of the direction that maybe we haven't been searching, or maybe it's not easy for us to search. Those are the ones that I think we've got to be more, you know, careful about, you know, essentially look more carefully, get better sky surveys. So that's my opinion anyway.
Yeah, when we talk about extinction events, you know, they never seem to make extinct things like mosquitoes. You know, bring to extinction, you know, pests and the animals we could do without. You know, it's always bunny rabbits and you know, like our favorite little animals that get changed. Although the raptors, you know, that was okay. I'm not going to take both sides of that. This that was fun. Duncan is always great, wasn't he?
Yeah, it was fantastic. I wanted to have a very brief, if you would, just what are your final thoughts on Asteroid Day? As we, you know, it's actually not Asteroid Day here in the UK. It's 10 past midnight. But what are your thoughts there in the US about this event and what it really means?
Well, hopefully it raised awareness. That's the first thing. They're fun. We've been looking at these images that Slooh members have taken of various asteroids. We're seeing one now passing by. We looked at Icarus live. So it's not just, you know, thinking about them. We actually have the real McCoys, the real characters as they're zooming past in the night. And so there's a lot of different angles. They're pretty, they're fascinating to watch. They're a little scary because, you know, they did end the reign of the dinosaurs. An asteroid, it was either an asteroid or a comet, did injure 1,000 people just 2 years ago. So, you know, it's certainly makes us want to be aware. So the thought was, it's good that we did Asteroid Day. What other kind of day could we do? You know, we have we don't have Sunday when everybody worships the sun. Is there another class of object? I'm taking over your role as host, actually. I'm asking the questions now for the moment. But what do you think? Is there another class of objects that we should make it the day of the comet? Do you
I
think, or
think
what?
there's a huge possibility for all sorts of days here on Slooh, and I'm sure over the years we're going to have loads more. But I think on that thought, we'll leave it. Maybe you've got some ideas out there on Twitter. Do send them over to us at Slooh. But thanks, Bob, for speaking to me. Thank you also to Richard Garriott, our guest earlier in the show, and also Duncan Kopp for speaking to Bob. Thanks to the production team for helping us get those fantastic live images from the Canary Islands. It's been wonderful to show these images to you, and thank you for tuning in. If you want more astronomy, if you want more Slooh, then in the clubhouse tomorrow we have that fantastic conjunction that's going on tonight and tomorrow night that Bob was talking about earlier. Venus and Jupiter coming really close together in the sky, and we'll get those live pictures from our telescopes. So look forward to that in the clubhouse. We hope to see you there. But from me and Bob, thanks for tuning in, and we'll see you again next time. Good night.